Welcome to the deep dive. Today, we're really strapping in for a bit of a shortcut, you could say, into infrastructure knowledge.
Yeah, we've basically pulled out the absolute core concepts administrators need, the things you have to know to keep complex systems humming.
Exactly. And we're drawing this straight from practice material, stuff that outlines the essential tools, the metrics you must master for cluster operations.
Our goal here isn't just listing answers. It's about turning that list into, actual operational knowledge. We're focusing on resilience, monitoring, automation.
All within that hyper-converged framework. We're using the Nutanix ecosystem as our blueprint today.
Precisely. Because if you're prepping for something like the NCA 6.10 certification, you know it's demanding. You need that solid foundation.
Right. We want to go beyond just defining terms and really get into the why. Why these specific tools? Why these settings? They're not just suggestions, are they?
Not at all. They're pretty much non-negotiable for system health, for stability. We need to understand the principles that make a bunch of machines act like one reliable platform.
Okay, so where do we start the foundation, I guess?
Yeah, exactly. You have to begin with the basics, setting the rules for what the cluster can do, and importantly, how it handles failures, because things do fail.
Okay, capabilities first then. When a company gets this tech, what's that baseline license? The one that gives you core storage, virtualization, the essentials.
So that entry point, the foundational tier, is the starter license, sometimes called standard.
Starter or standard, okay.
And a key thing is what it actually enables. You get your core storage management, data protection, basic scaling, and critically, it supports virtualization using their own hypervisor, AHV.
And AHV. Just to clarify, because people come from different backgrounds, it's not like a separate thing you have to install and manage,
Yeah,
is it?
absolutely not. That's a major advantage. It's integrated right in, makes the whole stack much simpler.
Gotcha.
And importantly, that starter license also gives you Prism element. That's the management interface we'll be talking a lot about. It's got everything you need to, power on VMs, manage the storage. It's the basic toolkit.
And the higher tiers. Pro, Ultimate.
Yeah, that's where you get the more advanced stuff. Things like complex security features, deep performance analytics. But starter, it gets the core job done.
Okay, license sorted.
Yeah.
But like you said, things fail, hardware breaks. So fault tolerance is critical. How do you balance being resilient against, using up too much storage? What's the absolute minimum needed for data durability?
Right, this is a big one. It's replication factor 2, or RF2. This isn't really optional. It's the baseline for data resilience. You absolutely need it.
RF2. So explain that. What does it mean in practice?
It means every single piece of data, every block, is stored on at least 2 separate physical locations, so 2 different nodes, or maybe 2 different drives across nodes.
So if one node just completely dies, the system finds the duplicate copy somewhere else.
Instantly, yeah. The service continues.
But why RF2 specifically? I mean, RF1 would save loads of space, right?
Well,
and RF3 would be even safer.
That's the classic trade-off, isn't it? RF1, just one copy. Well, if that hardware fails, your data's gone, or at least unavailable. That's just not acceptable for production.
No, definitely not.
So RF2 is mandatory to survive that single failure. RF3 protects against 2 failures happening at once, which is great, but look at the cost. You're using 3 times the raw storage instead of 2 times.
Yeah, big difference.
So for most situations, RF2 hits that sweet spot. You get the required fault tolerance, but the storage overhead is, manageable. It's the essential safety net.
And doing all this heavy lifting, the replication, that's the CVM, right? The controller VM.
Exactly. The CVM is the brain behind it all. There's one running on every single node in the cluster.
A VM running on each physical machine?
Yep. And that CVM essentially is the storage software. It manages all the I/O operations, compression, deduplication, and, crucially, the replication for RF2.
So when my application writes data,
it writes to the local CVM, and that CVM immediately makes sure another copy is written synchronously to a CVM on a different node. It's like a distributed OS just for the storage.
Okay, foundation set. We've got the license, we've got RF2 enforced by these CVMs, keeping our data safe. Now, how do we actually see what's going on? We need that admin cockpit view. Where's the first place you look in Prism Element for that quick health check?
Your first stop almost always is the home view, or the dashboard view. Think of it like a air traffic control. It's not for deep dives, it's for a quick status check.
What does it show you?
Gives you that immediate rolled-up summary. Overall system health, CPU usage, memory, storage utilization, and really importantly, any active alerts or warnings that need attention now.
So green is good, red means investigate.
Pretty much. If the dashboard's green, you can probably relax a bit. yellow or red. It tells you where the pressure point is.
Okay, that's the what's happening right now picture. But what about accountability? Who did what, when? If someone changes a setting and causes an issue or powers off a VM by mistake, how do you trace that?
Right. For that audit trail, you absolutely need the events section in Prism element. This is your detailed chronological log of system activities.
Everything, like user login.
Everything. User logins, config changes successful or not,
Yeah.
VM power on off, maintenance tasks, automated system actions. It's all logged there. It's indispensable.
Can you give a quick example? Why is that log so critical?
Oh, sure. Imagine you get paged at 3 a.m. Critical server just rebooted. Panic stations, right? This is hardware.
Yeah, it could be anything.
But you check the events log first. And maybe it shows user admin Bob logged in from this IP, initiated VM power cycle just 5 minutes before the alert fired.
So it wasn't hardware failure at all.
Exactly.
Yeah.
Suddenly it's not a hardware hunt. It's a why did Bob reboot the server conversation.
Oh,
Or
yeah.
maybe a policy issue. It gives you that crucial context for troubleshooting and compliance too. It's the system's memory.
That makes sense.
Yeah.
Essential for keeping control, especially in bigger places. Okay, let's switch gears to something that makes every admin a bit nervous. Maintenance, upgrades, patching. We know we have to do it, but how do these modern systems handle rolling updates, firmware, software, hypervisors, without, taking everything down? There must be automation involved.
Oh, absolutely. It has to be automated these days. And the main tool for this is the Lifecycle Manager, or LCM.
LCM, okay.
This is seriously powerful. It tackles the complexity of keeping this tightly integrated stack up to date. LCM handles firmware updates on the nodes, updates to the hypervisor like AHV, and even updates the CVM software itself.
So what makes it smart? Why does it take the fear out of patching, like you say?
Well, two main things. First, it does everything in a rolling fashion, one node at a time.
Right, so it doesn't take the whole cluster offline.
Exactly. You use that RF2 redundancy we talked about. It'll move the VMs off a node, update it, bring it back, then move on to the next one. Minimal disruption.
Okay, that's clever. What's the second thing?
Before it even starts, it does extensive compatibility checks. This is huge. It knows which firmware version plays nice with which AHV version and which platform software version. It won't let you install something incompatible.
But what if something goes wrong during the update, like a network glitch or a check fails halfway through? Automation isn't always perfect.
True. That's where the validation comes in. If a pre-check fails, LCM just stops. It won't proceed if the environment isn't stable.
Okay.
And if something goes really wrong during the update itself, it's designed to try and maintain cluster function, potentially rolling back if needed to keep data available. It's built for safety during those risky update windows. Definitely working smarter.
Right. LCM keeps things up to date and stable. But even a perfectly patched system can feel slow if resources aren't right. Let's talk performance. If you want to know how fast things are really running for your applications, what's the absolute #1 KPI, the metric you obsess over?
This one catches people out sometimes.
Yeah.
A lot of folks jump straight to IOPS, input-output operations per second.
Yeah, sounds of speed. More operations per second must be faster, right?
Well, yes and no. The truly critical KPI, the one that tells you about responsiveness, is latency, usually measured in millisecond LOPS.
Latency. Okay, why is that more important than IOPS?
Think of it like this. IOPS is about volume. How many cars can get onto the highway per minute? Latency is about how long it takes one car to actually get from A to B.
Ah, okay. The travel time.
Exactly. Your user running their application doesn't really care if the system can handle 1,000,000 IOPS if their specific click takes half a second, 500 milliseconds to respond. That's high latency.
That's a really clear way to put it. So high OPS is good, but only if latency stays low. What if you see high IOPS and high latency?
That's your classic sign of congestion. The storage system just can't keep up with the demand. It's overloaded.
And high latency, but low IOPS.
Now that suggests the bottleneck might not be the storage itself. It could be a slow application, a network problem somewhere else, maybe one specific VM acting badly. Latency is your first best indicator of actual application performance issues. It dictates that end user experience.
Perfect. Low latency is what we want. Okay, sticking with storage. How does this system optimize where data lives? Making sure frequently used stuff is on fast storage, less used stuff on slower, cheaper storage, and doing it automatically.
Right, that capability is called data tiering. It's a built-in automated feature to basically maximize speed while keeping costs down.
How does it work?
The system is constantly watching how often data blocks are accessed. If data is being read or written a lot, we call that
Right.
hot data, it automatically gets prioritized and placed on the fastest storage tier available, which is usually SSDs.
And if I stop using that data frequently, if it cools down?
Then non-disruptively, without interrupting anything, the system migrates that cold data to a lower cost, higher capacity tier, typically HDDs, maybe slower flash, depending on the setup.
And this is happening all the time behind the scenes.
All the time, continuously, automatically. You get the performance benefit of flash for your active data and the cost capacity benefit of slower media for older data, and the admin doesn't have to manually move anything. It just happens.
Completely transparent to the applications running on top. Okay, before we jump into some specialized services, let's just quickly cover a very basic VM task. I've created a new VM using AHV. Now I need to install Windows or Linux on it. How do I get the OS installation media attached?
Yeah, fundamental step. You use the update VM function, and within that, you choose to attach a CD-ROM ISO.
Okay, update VM.
Yep. You basically point the VM's virtual CD drive to the ISO file you've stored somewhere accessible, like on the cluster storage. The VM then sees that ISO as if it were a real physical disk, boots from it, and you can start the OS installation. Dead simple.
Got it. Attach ISO via update VM. Okay, excellent. So we've covered the foundations, the performance monitoring, the day-to-day management stuff. But these clusters aren't just for running generic VMs anymore, are they? Let's touch on a couple of specific services that run on this infrastructure.
Yeah, definitely. Two big examples are file services and database management. So if a company needs traditional file shares, home drives, department shares, SMB or NFS access, but once it's scalable and highly available, they'd look at Nutanix files.
Why not just build a standard Windows or Linux file server VM? What's the advantage of using the dedicated files product?
Well, it's really about the scale-out design and the integration. A single file server VM can become a bottleneck, right? Nutanix Files runs as a distributed service across multiple nodes in the cluster.
So it can grow performance and capacity just by adding more nodes.
Exactly. Scales horizontally. And critically, it's integrated. It uses the cluster's underlying RF2 data protection, the CVM intelligence, the LCM for updates. You don't need a separate physical NAS box or some complex third-party file system to manage. It's all part of the platform.
That integration sounds like a huge plus.
Okay, last area, databases. Managing things like Oracle, SQL Server, Postgres. It's complex. Patching, cloning for dev tests, backups, it takes a lot of admin time. Is there a service to simplify that whole life cycle?
Absolutely. That's where the Nutanix database service, NDB, comes in. Its core purpose is delivering database as a service, or DBase.
DBase. What does that mean in practical terms? What does it automate?
It automates those really painful, repetitive, time-consuming tasks. Think about patching, like you mentioned.
Yeah, patching 50 different database instances.
Yeah.
Nightmare.
Right. NDB can automate that across different database types using simple policies.
Yeah.
Ensures consistency, reduces risk. But maybe even more powerful is cloning and provisioning.
Making copies for developers. Yeah. Need the fresh copy of that huge 10-terabyte production database for the test team. Traditionally, that could take days. Copy the data, restore it, configure it. NDB can provision a space-efficient, fully functional clone in literally minutes.
Wow, okay. Minutes versus days.
It's a game changer for speeding up development cycles. It's taking that automation concept right up to the application data layer, reducing admin burden massively.
So NDB handles the heavy lifting for those critical databases, letting the DBAs focus on more strategic stuff.
Precisely. Turns those complex manual workflows into simple self-service clicks.
That was a fantastic run-through of the essentials, a real deep dive. Well, thank you for joining us on this deep dive into cluster operations fundamentals.
Yeah, thanks for tuning in.
We'll catch you next time.